Hey everyone, welcome to the OpenUSD Insiders live stream. I'm very happy to have you join us, and I'm very happy to have these amazing guests here. We have a very interesting topic today that I think is going to make a lot of people happy once they see what we're going to be diving into and doing some show and tell. My name is Edmar Mendizabal. We're going to be digging into something which has come up a lot since GTC San Jose and Hanover Mesa, and that's the gap between where physical AI needs to go and where digital twin creation currently stands. Basically, physical AI cannot scale on real-world data collection alone. We need synthetic environments, we need simulation at scale, and that means we need digital twins. But if building those digital twins is still a manual, painful process, then we have a big bottleneck that kind of limits the entire pipeline. So to set the stage here and discuss this in greater detail, we have my colleagues, NVIDIA's Raphael Bohm and Paul Cutzinger. They're going to walk us through the current state, along with some nice commentary from Michael along the way. Why are digital twin workflows still so manual? What breaks when teams try to scale simulation environments? And where are the bottlenecks between 2D assets and usable 3D worlds? And why does all this matter for physical AI? And then towards the second half of the live stream, we're going to hand it over to our ambassador here, Michael Wagner, founder of SyncTwin, who's going to show us what it looks like when AI agents step into that workflow and start closing that gap. Not sometime far in the future, like now, like today. It works. I think everyone's going to be blown away. And a very special bonus treat that Michael just shared a few minutes ago in our warm-up is he's going to show a quick way to leverage an Omniverse library called OVRTX into a quick little Hello World type of tool. Because I know a lot of people want to dig into leveraging libraries, and he's going to show you how quick and easy it is. We're going to take your questions live throughout this program, so feel free to put them in the chat. The more on topic your question is, the more likely we are going to talk about it right on the air. You can always leverage our Discord and other places for other off-topic questions. And I'll try to help in the chat as much as I can during the conversation. We're going to cover some news towards the end of the live stream, so tune in to the end if you want to hear about some exciting things happening, including GTC Taipei, which I'm about to catch a flight to tomorrow, actually. Some very exciting stuff happening all next week, including Jensen's big keynote on Monday. We'll talk about that more in more detail later on. But first, let's kick things off and do a quick round of intros. Raphael, I'm very happy to have you join us here today. Why don't you shed a little bit of light about what your role is here at NVIDIA?
Yeah, happy to do so. Thanks for the invitation. So my name is Raphael. I'm a product manager in the Omniverse team, and I'm also responsible for digital twins, physical AI, which leads to the fact that Michael and myself, we know each other since a couple of years. And the funny story is our first met was when I handed over 2 GPUs to Michael for a demo in Omniverse. So this is how it started.
Did he give them back, or did he still have those?
Yeah. I brought it back, but he tried. Now he has some great GPUs, and yeah, we're working super closely together. Met at Hanover Messe. Looking forward to the next event. So yeah, glad to be here.
Oh, that's great. We're glad to have you. I'm also very glad to have actually my old boss, coincidentally enough, Paul Cutzinger, boss, probably my shortest term boss ever. but those are some great days. Paul, why don't you let everyone know what your role here is in NVIDIA?
Hey, I'm on the developer relations team, so I get to work with all the coolest tool makers on the planet. And that's how Michael and I got to meet. We were looking for cool tool makers, and of course, SyncTwin always bubbles up to the top of that. So we've also been talking for years. This has been great to see this all come through, Michael.
I'm so glad to have all of you, 3 of you here together. And of course, we have Michael Wagner, who's Omniverse ambassador from the community, for actually one of our first ambassadors. Michael, for people who don't know his background, he's been on the live stream a few times because he's doing amazing work year in and year out. One of his first big use cases was for Omniverse way back in the early days, actually working very closely with a car manufacturer that most everyone will know called BMW. And helping to create their factory digital twin. Michael has since created a startup called SyncTwin, helping companies of all sizes leverage digital twins. Michael, I'm so happy to have you here. Why don't you fill in the gaps on so people know a little bit about your background and what SyncTwin does?
Yeah, thank you, Edmar, for having me. And yeah, as Raphael said, I was in the early days of Omniverse creating first little demos, and I just had like a 260 RTX or 270 graphics card, so I went. I was a little short on power, so I just asked Raphael, and he said, "Oh, I've got two cards. You can come and pick them up." So I drove to Munich, and we met somewhere outside, and he handed me the card. So that was really nice, and so we got a good demo going. So and since then I'm hooked on Omniverse and OpenUSD workflows. And starting with the OEM, I'd like to make this available to the small and medium-sized enterprises, basically, which have a lot of potential, basically to using and leveraging these, especially agentic enabled workflows.
Amazing. Well, we're very honored to have you here. Thanks for making the time. I know it's a little late there in Germany for both of you guys. So let's get started and talk about the current state of digital twin creation and why are workflows still so manual for many people. And Raphael, maybe you can help us dig into this a little bit.
Yeah. So there are a few challenges or problems, if you will, but one of these existing problems that are in place since a couple of years now are so-called transition layers everywhere. Because when we talk about digital twin workflows, we have different assets, 2D assets, 3D assets, all mixed together, photos, PDF files, spreadsheets. And when we, for example, look at 2D assets, like photos or schematics or plans, 3D models in comparison, they require some kind of human interaction at every step. So, for example, a 3D asset representing a sign is a shape in 3D, but it's not a 3D model. And for example, those 2D assets, like a floor plan, they go through many workflow steps, like an engineer, a planner, a 3D modeler, a scene assembler, somebody who puts some metadata or some annotations on it, maybe a simulation engineer, and every kind of handoff introduces or creates some delay because not everybody is available. So we're talking about days to hand it over. We're talking about errors. Knowledge is not often handed over properly. So there are some dependencies, and you can see that it scales from handoff to handoff. And when we talk about these so-called last mile to get those 80% automated to production ready, it still needs a skilled human person to fix, for example, edge cases. So, and this transition is very complex and very cumbersome, but it's in place since years. That's one reason why those workflows are still so manual, because there are many people involved on many different levels, and to kind of consolidate this is not easy. It takes time. It needs really some push and will to do so, because there are also a lot of legacy formats included. For example, like DWG, DXF, and others. File formats well in place since years. If you look over the border on different assets, there is a mismatch because, for example, 3D catalogs are not automated. They just exist because they exist. There is a drawing, but it's not in the library. Okay, what is it? And those things. So that's why it's really complicated. There is also kind of this behavior like never change a running system. It works. Why should we change? But it takes just longer. So it's a lot of manual effort on those different levers, and that's the reason why it's still a lot of manual work involved in those workflows.
This is really one of the reasons I love what you do, Michael. Every one of those things you just mentioned, Raphael, has a really good reason for why the source data is the source data that it is. But then when you want to bring it to a twin, you've got work to do to get it there. And a lot of times when you look at the ROI of these kinds of things, you're thinking about one project and doing the data conversion. And then later you think, I'm going to do a second project, and you do the data conversion. You do the third project, do the data conversion. And a fourth project, do the data conversion. And so a lot of what I've seen you do, Michael, is to say, like, let's do for the first project, let's do the data conversion, get it into USD, get it all working. And then, hey, for the second project, now your cost is lower. And then your third project is even lower. And you just start to be able to get more and more value out of all these different projects that are going, versus have to redo that same thing every single time for a bespoke purpose. So it's kind of a neat way to get started at the lowest cost possible, but then scale as you start to find more and more simulation needs.
Yeah. And gradually also change your workflows, right? Because you're forced or you're encouraged to think about your data and how it flows and about the processes in the organization. I think that's also a bonus.
Yeah. Very much so.
If you one more comment is on when we talk about validation. So validation still requires some domain expertise, because if you look at the layout, okay, does this layout make sense? If you look at it, yes, this material flow, this layout, it makes sense, but it's not a geometry question. So, and that's one thing where human interaction or domain expertise is still heavily in use, especially also on 2D assets. What does it represent? Is it a sign? Is it a text box, or what is it? So a human person can interpret it, but software struggles here and there a little bit. So that's why there is a lot of domain expertise needed to finalize those plans and digital twins at the end.
It's the semantics, basically, of the digital twins. Yes.
You muted, Edmar.
Sorry, my mouse. I have 4 monitors, and I have to try to find where my mouse is. But I wanted to say that we have a bunch of people watching right now, and absolutely post your questions as you guys have them in real time, and we will try to tackle them as long as they're on topic. So I hear a lot of mention of manual, and I'm assuming that this is where agentic and AI agents kind of come in to help fill that gap. Is that correct?
I would say so, definitely, because for example, when we talk about AI agents, we're not talking about one agent. We're talking about, let's say, multiple agents, because those agents they do not work alone, because multiple agent forming or representing are building those pipeline with the human in the loop checkpoints, so for example, when I'm working with my agents, I'm acting like an orchestrator to manage all those different agents. I do have a asset agent, I do have a QA agent, and some others, and these agents are representing different, let's say, skills. For example, some semantic understanding. Okay, does this 2D plan look like the plan I'm working for, or identifies objects, reads some symbols and those things. There is another agent that looks into a catalog, identifies objects if they match with what is on the plan. There is another agent, for example, that is doing the spatial reasoning to place those assets that has been found in the library. Is this the right place? Does it face the right direction? Is it connected to this machine, or should it be somewhere else? There is another agent that is responsible for annotations to document, to enriches the scene with those information like physical props, materials, operational parameters from spec sheets. And then maybe at the end, there is a QA agent responsible for the validation, is doing some collision checks, reachability analytics, compare different versions, scan data versus photos versus 3D data. So when we talk about AI agents, there are multiple agents you can work with, you should work with, and every agent represents a special role and responsibility. And as a team, you can build great things way faster, but there is still this human in the loop, because there are some things you really need to justify and say, okay, yeah, that's the right thing. No, review, go back, do it the other way around because it does not look correct to me. So it's like kind of a back and forth and like a team effort, if you will, to work with those agents.
And even more, there's more than a human in the loop, there's a tool in the loop. So these agents make use of tools, and those tools have really good jobs they're good at doing, but they don't have the context to know that they should be operating and doing something right now. So the agent is the one that can sort of orchestrate them to do that. And so you have agents that are very narrowly focused on operate a tool, or agents that are more broadly focused on orchestrate them. And it changes the way, like this is my Telegram right now, and I've got it running, it's building a factory. And so far I've built 20,000, this factory has built 20,000 parts, and it's run over 12 days through IsaacSim simulating this sort of workflow. And it sends me an update every 2 hours to say how it's sort of going. And as Raphael said, there's a lot of sub-agents that are doing their own parts of the job, but it takes me to get in there and go like, well, hey, I actually need you to do this, or what if we change this thing, or let's focus on something. So there are parts around like random CAD file, like I had it building stuff from Onshape, for example. Well, that needs to be sim ready because otherwise I can't have my robots get in there and so it can apply materials and put the grabber points on them and all that good stuff. And then it calls the various tools to place the objects and to move them down the conveyor and to, we've got to get Fanuc arms who are sim ready. And now Fanuc arms can be placed into the scene, and now they can be manipulated to move around in there. So you need that whole consortium of people and tools and sim ready objects in order to actually make the system think it's in the real world. That's the whole objective, is to make it seem like it's the real world, so that when you go to take these brains and put them into their forever bodies, they will know what to do and they'll act properly.
Exactly, and that's one of the kind of killer arguments why we need physical AI, or why physical AI is so powerful. When we talk about, let's say, robots or autonomous vehicles or humanoid robots, they need to be trained, and they need to be trained in synthetic training environments created with synthetic data generation, so they can act physically correct. And they need to be trained in let's say, thousands of environments, because you cannot train a robot, let's say, in a cartoon world and then expect it works in the real world. So just as an example, if you would like to train one robot task, let's say in up to 10,000 environment variations, and the factory does have 100 plus different zones this robot is acting, you can scale it up to, let's say, 50 factories. We're talking about 50 million simulation environments needed. And to do this manually, that's impossible. But with AI agents, it's feasible. Like you said, Paul, it's running since how long? 2 weeks now? Or
yep.
So
286 hours of uptime. It's been running 11 days, 23 hours, and 31 minutes.
So, so that's a lot. That's
just
really
around the
a
clock.
lot.
Yeah. And then it gets mad at me every once in a while. It's like, hey, Paul hasn't responded in 8 hours. Maybe he's sleeping. And so I'm like, oh, sorry, dude. I gotta get back on it.
I ran my bot here, and then nothing happens for 6 hours. And then I was asking, like, are you still awake? And I'm working.
Yeah.
Don't disturb me.
There was a question in the chat from Tom around MCPs, and is it best to keep all the logic in the MCP servers and MCPs? I think you got to make decisions about this. MCP is a great first order thing. Sure, put it all in there, and that's fantastic. The challenge with MCP tools is that you absorb all of the information in them into your context window. So when an agent picks it up, it has to read all of the instructions plus the APIs for all the tools. So it's fine, especially if your tool is going to be using that a lot, or if your skill is focused on using that particular MCP tool, or maybe a set of 2 or 3 MCP tools. Great. Yep. Keep it all there and keep it loaded into their context. It's perfect. If you've got a situation where you have many MCP tools, like imagine an infinite number of MCP tools for all the things you're going to do, well, then you probably don't want all of that every time. So you probably want to have some sort of routing logic that would allow a description of all the tools that are available. And in fact, even a description of which agents are the best to go make use of those kinds of tools. And then that sort of routes you around. And then in turn, that loads up the MCP tool. So sometimes it's best just to have a straight CLI access and they can just interact with the API directly. Sometimes it's better to use an MCP tool because then it's got all the characteristics you would want to have about it. And sometimes it's better to just have like a routing table with your orchestrator. So I would say, like in your first order proof of concept thing, sure, throw it all in the MCP tool. And then you get into optimizations and start thinking about a little bit deeper, then just plan it out a little bit more.
Thank you for that. That was a great question, actually. I was curious about that myself. So that's coming in from Dylan Tobin, actually, who's an Omniverse ambassador. So thanks for
sorry, I thought it came from Tom.
No, he has a nickname. I know his alias. Okay, so I know, Paul, you have a hard stop at half. I
do. But let's see what Michael's got to show. I can't wait.
Yes.
So exciting.
Michael, let me know when you want me to share your screen. I see. Did you want to play that video first, or?
I just wanted to comment also about the MCP. The context is just the right thing to decide. But actually, the OpenUSD stage or like what you're operating on is like the context, and then you can choose an MCP for this kind of task. Maybe also what Paul showed with the NemoClaw. I think it's an example how we change from an expert talking to an expert tool and doing some things. The actual user talks to the bot and to the agent basically, and then the agent talks to the expert tools, which are basically MCP servers. So and that highlights it very nicely in my opinion.
Very nice.
I can.
You want to share your screen here?
Yeah.
Okay.
So
I think we're looking at the video now, or now we're seeing the slide.
Just to it fits so perfectly. I just show this first. Right now, we're using a lot of expert tools to create our digital twin environment, like for material provisioning, for workspace ergonomics, for the BIM models, and so on, and everything like creates an aspect of this holistic digital twin, and everything is integrated in like this layered collaborative digital twin in OpenUSD, which is this common language to integrate everything, and this, as you see, it changes from directly interacting with the expert tools, but having agents with skills interacting with different expert tools depending on the context. I think that's basically the change we are experiencing right now. So we go from like this humans using expert tools to an agent. I call it agentic digital twin pipeline or digital ultra. I would call it which basically agents interact and you as a user, as a human, interact with agents who themselves interact with MCPs and expertise provided by these servers. That's just perfectly corresponds with what you just showed, Paul. So 2 years ago we presented our first vision video of this.
Hi, I'm Lucy,
an agent
your
you
digital twin
interact
AI
with.
companion. The Sync Twin app, powered by NVIDIA Omniverse and
coming now
OpenUSD, is your key to next
Michael, we
level
can't hear you
digital.
very well.
You might want to pause the video, but when you play the video, maybe mute your mic.
Into the app and see how your factory evolves. Need something specific? Just ask. For example, Lucy, create a pallet rack. Or, please add forklifts and loading units. Optimize your processes with tools like NVIDIA cuOpt, streamlining operations to deliver real value from your digital twin. To make smarter and more efficient decisions. Or dive into VR and become one with your factory to understand and engage with your operations on a whole new level. Do you like to know more about what I...
Just so far, to highlight, this was 2 years ago, and now we have Nemo Claw basically doing this as an agent. So this is so cool to have like now all these different tools to actually work with. And yeah, you basically build this agentic digital twin pipeline, as you said, from all the data sources available to you. So it might be an Excel file or a Visio document or a PowerPoint, but with agents or LLMs, you can actually pull out the information and transform it into, in our case, OpenUSD in a form that everybody can consume and relate to. And this is just great to have OpenUSD here as an enabler. And let's go into our factory. So we have created a little factory in order to show the different contributions of expert tools. And along this, I'll also show you how we actually then transformed the use of expert tools to actually calling MCPs and agents of that, and how we show a little some workflows as well, where we get 2D data, maybe not just textual data, and transform it into USD components and then use it in our environment. And let's just fly a little through the factory, and we see the different
Michael, can I just inject one thing real quick? This is all the things you've said so far. It's a real opportunity for the development community out there in the world, because what you've shown is this network of tools that get the overall job done. And it's never been more possible for the independent tool developer to find a really cool niche thing that they can solve really, really well, that can be stitched together into a larger scene. Before, if you built a really cool niche tool, what opportunity do you have? Because you're not going to go to BMW and just knock on the door and say like, hey, buy my niche tool. You're too small for them to be able to deal with, and they don't even know how to pay you, right? So like just getting an agreement with them is really hard. And so, but now with what Michael is showing here, you've got a sync twin integrating with many behemoth players and integrating all sorts of indie players all together to build out this end-to-end workflow. And so I just think it's, as you watch what Michael's about to show, you can see the opportunity, and it's a different kind of opportunity that's been available in the past many years, right? It's also opening up not only for the really large companies like Michael's used to working with, but also, as he said in the beginning, these smaller players who in the past weren't able to afford tens of millions or even more of automation infrastructure before you can get things going. But now you can have really lightweight, nimble, autonomous infrastructure with these really lightweight, nimble, bespoke tools all stitched together in this fabric, like Michael's showing with Sync Twin. It just really opens up the TAM, the addressable market for all sorts of things, and it opens up the development community to build these kinds of tools and stitch together. So hopefully you'll recognize your spot in this whole flow that Michael's about to show, and find a way to plug in.
It's a great way to explain
it. Definitely. So just to show you here, for example, we have over 10 different companies providing content from their expertise. Here we have Ideal Works with their shop floor, like their robot fleet, and here we have actually 3 different companies with a virtual commissioning, combining human simulation with IMK and Epolog with the material provisioning racks. And so from also scanning environments, I'll just give you a quick tour, because everything you see is also like the product of an expert tool here. Rico, for example, they use a agentic approach to segment these scans and make them actually usable and augment them with meta information. So this is basically a tool, table which I can move and put things on, just flying to the actual site, which is today a laboratory environment. Here, this actually was created from a Visio block layout. I just quickly show it. The different areas here, the blue things, they come from this Visio layout, for example. See, this is a rough like planning layout in Visio, like just a 2D document tool. But we have connected this and created a little connector MCP, which is notified whenever this changes, basically, and transforms it into an open USD component. And not only, as you see here, it's like not only shapes, but also it's meta information, right? It's and we take all the information out of this source and transfer it to the USD.
Michael, how long did it took you to build this connector?
Oh, that was not so hard, because I mean with a few days, yeah, because right, and we did this like years before. So now with Cloud Code, it's like a matter of yeah, a day or hours, I'd say, you know. And I in the end, I'll show you a little demo. I just did it like in the last hour. So yeah, you really have powerful tools if you know a little how to program on your hands right now, and it doesn't get worse. It only gets better. So yeah, times are really great to be in this space.
Because it also identifies maybe some optimization opportunities in your software to make maybe the connector faster, or maybe add additional features to it. So that's also something we're doing on a regular basis now, to rebuild existing solutions and optimize it at the same time with support of agents, to make them better, to make the performance faster and those things. So this is super helpful.
Yeah. And also like now when transforming like your this was actually a normal kit extension, right? And we used we transformed it into an MCP, right? Because it has a fast API interface, and you can just like then add this MCP server functionality, and while you're doing this, you can also look into the code and see what can be improved. And so you see here we have added like here the space type or the zone name. This comes from the metadata from Visio, and this provides us a first anchor point in our 3D environment in order to work with it. And now we can, if we have an agent which we can tell, oh, look in the factory at this Fertigung area, right? It's like assembly area, and put some things on it. So it already knows the place because you have added the metadata, and that's basically the approach we create here. So just to give you a little idea, we use a Python basically interface, and we create these block layouts, right? And this is just one. If you go back to this, this is basically this piece, right? And then okay, now we have like this our block layout, and I want to go now to a new area we haven't shown last year where we first presented this. It's basically a company creating equipment for laboratories. And these guys, they have a quite nice catalog in as a PDF, right? And as you see here, this is a laboratory environment, and this machine has actually been created just from information in a PDF catalog document, and some picture also in the website of this catalog. And so what we do also with agentic help, we need to do two things basically. We need to understand, as you said before, not only like the shape and these elements, but the semantics. We need to know this is this kind of machine, and it has like this weight. It's like that's a German, but it's like some table thing for laboratory, right?
I can read it.
Sorry, it's a German company as well. So yeah, that's basically what you pull out from the PDF, right? And we use here Claude Code to pull out an ontology. So we create like a class model of every object in this catalog. If we don't have any, so we some companies may have that already, so they don't need to generate it. But we can use agentic help to generate the actual class model. So we have tables, and we have like other equipments. The tables are in this and this and this size, and they're like for chemicals, or this is with wood, and everything is like then created in these classes, and that's some attribute of OpenUSD. You can work with inheritance. So and just let me quickly show how this actually looks.
That's such a great example, because I mean, imagine how many people are facing those challenges to only have some 2D images or some catalogs with some measurements and a table of specifications, but you need the 3D data, the 3D model in your digital twin to do some collision checks, to do some what if scenarios, to look, does it fit into my layout planning, or what happens if I change the layout in Visio? You will see immediately the impact, or how many machines can I place in this lab, and this opens up so many new opportunities, how to work with the data, or how to kind of migrate or upscale those legacy data in PDF, in Excel, in PowerPoint, in Visio. I mean, I can go on. This is a really great example.
And by combining these different sources, so in Visio, I have just defined. You see the little. If I zoom in, I just defined the spot where we want to place this machine, right? And so by just telling this, it's this kind of a product. We already have like a spatial relation. And then we augmented this with actually the information from the catalog, and from this PDF to USD catalog, we have derived basically these classes, right? It's OpenUSD, and the good thing about OpenUSD, it's also ASCII. You can read it, right? And so this is what the agent came up with the actual class structure. So we have a class product, which has these kind of attributes. We have a class media connector with these attributes. And that's just by looking and working through the actual information in the catalog PDF, right? And then we say, okay, we have this class Abzug, which is a product, and it has additionally these kind of attributes, right? and we have another class, or it basically generated these class definitions from PDF to OpenUSD. And then if we have this, we can actually use this and create a catalog in OpenUSD, right? Which uses the classes. And here is the concrete catalog entry, and we have used one element of this catalog to actually put into our factory. Here you see there are different variants with different attributes, and if we switch to our, that's exactly what you see here. This green arrow is basically the reference to the class definition. And see here you see basically all the different attributes taken from this catalog. And so now the question is, how can we actually get the 3D model? So now we just had the data attributes, and that's some thing where we have several possibilities. So in this case, I used a 2D image to 3D Gen AI provider. I also do different tests with 2D to 3D Gen AI, but this was, I guess, Tripo. And the agent calls the MCP basically calls then the web interface of these generators. So and now we get a nice 3D representation. See here it's Tripo, as I said, and we augmented this also into this OpenUSD structure. So that's very important that you have this hierarchy and this namespace, and you integrate everything and the different aspects of this digital twin come together step by step, using different tools, using different agents, which are actually either triggered by yourself, and Paul showed the example here. That would be the other thing to get 3D data or a 3D model. So we have our NemoClaw Telegram bot, right? And we go to the factory and take some pictures. Here, for example, we need a picture from the front and a picture from the back, and we actually create like a 3D model of the machine and can then like integrate them. And there will from this approach there will come a lot of different new capabilities or skills of these libraries in the Omniverse ecosystem to NewRec, for example, is already a tool which enables these kind of workflows, and so I think getting the real environment into the space is getting better and better. And maybe to give you a whole overview about how we think things will develop. As I said before, we have a digital twin asset pipeline in the center, right, based on OpenUSD, working with different process or physics simulation engines in the ecosystem, expert tools, and we have a lot of agents interacting with this digital twin asset in the middle, also acquiring real world data, and the user actually works by interacting with the agents, right? Especially an orchestration agent like NemoClaw, but also generating just the user interface for the job. So and this is something I also want to show next. How now we have our 3D data, we want to integrate something, a little tool which is missing. How can we leverage the libraries and the skills from OVRTX, for example, to create a tool which we can use as a user, or our agents as an MCP can also use. Yeah.
This is a great overview, especially when we talk about how to interact with those workflows or the agents. So you can prompt, you could use large language model interaction. You can also voice control it. I can talk to my Claude and describe, I want to build this and this and that, or you can take images and digitize it as an input, use this to do that. But this shows quite nice these different layers, how such an architecture with workflows can look like, and what the components and how many agents are even here involved to work on multiple tasks. So it makes complex workflows a bit more simple, because you can just prompt it, put this here, put this asset there, or as you showed, moving boxes around, and then it identifies exactly where this machine should be placed. So that's simplifying a complex workflow with help of AI tools and agents. So that's a great example.
Yeah, and we put it in on I've got a Spark, DGX Spark, to put my Nemo Claw on, and some large language models, or like 2D, 3D from 2D. And since you're on the Spark, you just grow and go to enterprise size. Like you're already on the right machine, right? So that's also a nice thing, that it just scales with your demand, I'd say.
That's your plan, right?
Yeah. Let's see where we end. But yeah, it would be nice.
Very cool.
So, yeah.
A lot of interesting comments and excitement in the chat. I didn't want to interrupt, but a lot of surprised people, I think, that you can do this type of workflow right now. So I think it's super inspiring. I posted some links in the chat for people who heard Michael mention NUREC a few minutes ago. Also for Omniverse libraries, which I think he'll show us also in a bit. I posted a couple of links there. One question though, Michael, people really loved the fly through, and we're curious. It was so smooth. What is your hardware you're using right now? What GPU is this?
Oh, it's an RTX 6000.
Yeah, I explained it. Okay, it's a nice one. It's a nice one. Yeah. So obviously
it looks like this.
Oh, nice.
Yeah, you bet.
Look at that. It's like a mirror.
Yeah.
Very so a great GPU, and obviously the more powerful the GPU, the smoother these that would be for you. There was a question here. Let me see if I can find it really quick. Let me see. Oh, here it is. How important is standardization, like she meant to say MCP, in enabling scalable multi-agent ecosystem?
Yeah, very, very important. And not only like MCP, but on the OpenUSD level. That's what the Association for OpenUSD, Alliance for OpenUSD, is about. And SIM-ready standard, for example, is also an important thing. You have to agree on something if you want to address a certain aspect of the digital twin, on the attributes and on the behavior, and what should be included for a certain use case. And there are a lot of things coming with the SIM-ready specification, because validation is an important topic. You want to validate what your agent is producing, right? And that's the same for coding as well. So that what brought me to adopting more test-driven development approach, because you really have to be sure that what the agent produces is what you actually want, and that's you can do that by defining the tests first, which should be validated in order to make sure that the code does what it should do. But also you have to validate the USD structures which come out of these agents. that they contain and look like actual for the certain use case that are correct.
Very helpful. And I did put the link for the AOUSD. If people want to find out more, I put it in the chat, but very easy to remember, AOUSD.org. If you want to if you or your company wants to get more involved, they're always interested in having more feedback and input from industry. So highly encourage that. Very cool. Yeah, Dylan Tobin, Omniverse Ambassador, saying we need a USD asset benchmark. Yeah, so it's definitely an evolving thing. So I think get more involved. AOUSD has actually a pretty popular forum, I believe, where people can also discuss the future of AOUSD. This question came up a little earlier, and actually Paul had to go. He didn't want to interrupt, but he did wave. He had another meeting, but he had called this question out that was early in the live stream. Maybe we can talk about this for a minute. Besides training robots, would these digital twins be useful for other types of simulations, like discrete event simulation?
You bet, yeah. I mean,
Definitely.
Yeah. It provides the common ground, you put the different expert tools, and discrete event simulation is also like an expert tool, and from my point of view, providing like this simulation type, and you derive some KPIs from it. You have plant simulation, visual components, and these guys have connectors, and they need also a scenario to work on, right? So OpenUSD makes this a lot of easier to actually get started.
We have a good question here. I think it's relating to the model we're looking at on the screen now. Is this specific model mesh or CAD style?
That's mesh, yeah.
Mesh.
There you go.
But it's super accurate. I mean, can you zoom in a little bit to show what LOD level we are talking about?
It's not that bad. It's just from one picture, so that's really
crazy.
Not too bad, yeah.
Not that bad. It's amazing.
And then we have a really nice user here watching who was kind enough to post in English and German, I think.
Nice.
Which model has been used to generate the 3D object? So you were using PDF, right?
Studio, yeah. But I actually created a benchmark, which when I used all the different models, I have to look up the link and compare them. And I mean, quality gets better and better and better. So we have all the different, there is like, I don't remember. I have to look it up. Yeah, that's a lot of different tools. Yeah.
Very cool. Okay, very nice. Let me see. And was there anything else in this you wanted to show? Did you want to dive into those?
Last thing, I just wanted to show now we have our 3D environment, right? And we have generated 3D elements, but for some use cases, we need to get 2D from 3D, right? So because we have to like a Visio, maybe we want to get back, or some presentation we want to have the top view, and so I thought, why not? Let's create a little tool for that and use what we have with the OVRTX library, which was released recently, and I'm gonna switch to the other laptop if that works.
Yeah, let me see. Let me know when you have it ready, and I'll share it. I think I see it. Let me take away this one and add this one. I think we're looking at your laptop now.
Yeah. So basically, what I used Claude Code for this, and I described I want to have a little MCP server which actually can make 2D out of 3D, right? And I've got this, and this is already the result. It's Claude desktop in this case, and it's using my MCP, which I just created, to create these 2D top view of an USD element. And it was like let's see. I just started with the OVX library, and maybe for you guys, that's really helpful. So because this is the OVRTX, you can download it from GitHub repository, and it comes with skills, and that's really a superpower because it gives your agent the knowledge how to do certain things, right? And by using all this, for example, it says like, okay, about writing attributes. If I open, it's a markdown, right? So we just go in and see that's what your agent reads, right? And so user use the skill when this user asks to write an attribute, set a property, and it gets some informations on how to do this with OpenUSD in this case, right? And so I started off here with this vanilla library repository, and I said, okay, I want to now create a little tool which basically creates this top view of a plastic drum. Let me quickly start the the Git app. It's to show you the actual 3D model. And yeah, it was like a matter of like an hour to create this this tool, which reads in a 3D model of this drum, creates a top view and renders it using the OVRTX renderer.
Michael, you need to confirm which app to launch.
Oh, sorry, yeah, yeah. And this is also something you just can download from and create your own composer as well. And so yeah, it just created went and planned and we created this together. What does it need? It needs a fast API endpoint and an MCP server. And yeah, we got a little back and forth, but finally, yeah, we got a working MCP for creating like these top view models. And here is the model. Here it's basically a sim-ready component, right? This is the model, right? And then I just here in the Cloud Desktop I say, okay, actually, yeah, let's do it again, or maybe you believe me, but yeah, let's I'd like to get I'd like to get a top view of this asset, right? And it's this drum. Yeah, and so then it goes and sees, okay, I have this tool as an MCP, right? And then it here you see the MCP running. It gets the request and it starts the OVRTX renderer, right? And it renders it. And here we go. Yeah, here it is. The actual top view of this element. And we can also then ask to create a floor plan element in OpenUSD, which represents this top view. Just quickly, okay, let's create a USDA from this, right? And it uses the other method we created with this MCP. Okay, already done. It created this top view. And if we then maybe just, so here is the top view it just created, right? Let's take this and add it to our scene and see what, oh, look at that. So it actually created this 2D top view element as an USD. And then you can use this basically, for example, in a floor plan or in a 2D environment again. And so we have like closed the loop from 2D to 3D to 2D. So
very cool.
Within minutes,
Within
right?
minutes. So cool to
Within
watch it work
minutes.
in real time. So I did put the Omniverse Library GitHub page in the chat. So there it is on the screen. But just do a search for Omniverse OVRTX library, and it should come up right away. I have a good question here from community champion and popular Discord user, Papa Chuck, otherwise known as Renan. So what is the sequence of steps? You start using the agent, then you provide the skills, then you told it to build a tool with OVRTX. Is that the right flow?
For like creating this,
Yeah.
The skill. Well, I started with the repository. Added like Claude Code, and Claude Code uses the skills provided with the repository, and I create the actual service, which is a fast AI service using the OVRTX renderer. And then I created like additionally the MCP server for that. For these, there are basically two functionalities: rendering the 2D and creating like this mesh from the 2D. And with that, I also created like a specification. It's a JSON file describing this MCP server for Claude Desktop in this case. Could do it also with a NemoClaw or whatever, right? Well, yeah, and that integrated this MCP into Claude Desktop, and then Claude Desktop can ask, because it's MCP, right? It's a protocol. What can you do? And then yeah, it basically just calls the correct functionality.
Absolutely amazing. Look at this. I love this coming in from YouTube. Dylan, also awesome. And a little earlier while you were working, we had some other people. Omniverse Ambassador Pekka Varis Wagner's on fire. Then, a quick reply to that: he is beyond fire. Michael, I think you've impressed a lot of people today, including myself. I love this. But I guess we just got a question, last minute question, but before, and we'll head to the news and I'll let you guys go. This is coming from LinkedIn. Are there also possibilities for special shadings?
That would be the question. What kind of shadings you mean?
Maybe textures,
yeah,
or apply materials.
Yeah, sure. Also, interesting. You can add like physical properties. It's also kind of shading if you want, or like yeah.
Well, Michael, amazing. I can't thank you enough for presenting today. Really, really amazing content all the way through. I want to ask, I'm going to let you guys go because I have a few minutes with the news, but I know it's getting late for Michael and Raphael too. So I'll let you guys go, and then I'll do the news with everybody who wants to hang around and hear what's going on next week in GTC Taipei. But before I do that, before I let you guys go, what are your last kind of words of wisdom that you want to leave people with? And if any of the viewers there who are watching this live and you maybe missed the first part, this live stream is available on YouTube, so you can watch it right from the beginning, right after this, at your convenience. But Raphael, we'll start with you. What do you want the main takeaway to be here? We covered a lot of ground here discussing how AI agents are transforming 2D to 3D workflows. What's the takeaway for you?
The takeaway is the technology is there. It's accessible. You just need to use it.
Yeah.
And it helps in so many situations, in so many cases, to speed up things like you just saw. I mean, I'm building extensions now. I'm coding with my agents, but I'm a mechanical engineer. So it still opens up a completely new world for me. So yeah, it's there. Just use it.
That's great. It's a great comment from a great community member here, Jeff. I feel like I'm buried in new stuff, just like a birthday every day, gifts upon gifts. That's so true, Jeff. And Michael, what would you like to leave people with today?
Yeah, use it, try it, and get to know OpenUSD, which is the basis for all these digital twin environments. And yeah, just get your hands dirty and play with it. I'm also doing a USD study group on Fridays. I'd like to invite everybody who wants to join at 3 p.m. Europe.
That's awesome. I'll put the link also in our chat in just a minute. You mentioned OpenUSD. I put the link for our open sourced OpenUSD learning content, so you can take this content and use it yourself in any way you like. I'll put it on LinkedIn here, and then I'll also put the calendar on the screen in a second. So Michael just mentioned he leads an OpenUSD study group for actually quite some time now. So if you're in that time zone, what time is it again? Your local time? It's CET?
CET, 3 p.m.
3 p.m. CET. Okay, every Friday. All right. And Michael is great about posting updates on his LinkedIn page. So I highly recommend people follow Michael Wagner. Just look for Michael Wagner SyncTwin. You'll find his LinkedIn page, and he posts updates every Friday or Thursday about his upcoming study group. And it's open to all. You don't need to have special permission. I think it's pretty awesome. And I believe one of our other Omniverse ambassadors was in chat earlier, Jan. And I think he's actually taken over the microphone once or twice at the study group.
Yeah, it's helping. It was nice. Thank you.
Michael, what about companies? I'm sure we have a lot of people here who are watching from companies that maybe want to work with SyncTwin and have your expertise. What kind of companies do you look to work with, and how do they get in touch with you?
Like small and medium-sized enterprises getting into the space and want to try it out and want to experience it, and I'm also eager to learn from your use cases as well.
Awesome. All right, I'm going to put the calendar here so everybody has it. And Michael, are you involved with the next event by Kai Park? Is that happening, a big summer event?
Yeah. Actually, it's in summer, and we'll show the current factory environment you just saw here. There are humanoids in it, and maybe we'll also show some agentic demo as well. It's in Berlin. Nice venue.
Fantastic. Well, all right. I'm going to let you guys go, and I'm going to cover the news now for the rest of our audience. But thank you, Raphael, and thank you, Michael. It's so awesome to have you here today.
Thank you for having
Thanks for having us. Thank you.
Thank you both. And big thank you to Paul Kutzinger, who was here a little earlier. Really helpful to have his insight as well. And now I'm going to dive into, if I can find the slides here, I'm going to dive into our next big event, which is actually GTC Taipei. As I mentioned earlier, I'll be headed there in just actually a few hours. Tomorrow I'll be headed there. But it takes place June 1st through 4th in Taiwan, in Taipei. Very exciting. A kickoff is going to happen with Jensen Huang, our awesome co-founder and CEO. He is preparing now for a presentation that will blow people away. That is going to happen in the morning Taipei time. For everyone else, it's going to be live streamed globally. You don't have to be there to watch it, and that replay will be available if obviously if you're sleeping at the time when he gives it. But I highly encourage it. Add it to your calendar. You can go to that QR code to give you all the inside information about GTC Taipei, including the keynote. But I highly recommend you add that keynote to your calendar, and you get a reminder to watch it, because it's really not to be missed if you want to stay up with the latest that's happening in the world with everything NVIDIA is doing and partners are doing. This is 11 a.m. Taipei time at the Taipei Music Center. I'll be actually watching it from a local university at a watch party. I'll be watching it with some students. I'm really looking forward to that. Thanks to Max for helping with that in our team. We're going to have physical AI days at GTC Taipei. These are curated sessions specifically around physical AI. That QR code will show you more information. The great thing about these events, GTC events, is that we put that content out there for everybody else in the world who couldn't make that event literally within hours after the event happened, usually within a day or two, or sometimes maybe within the first week. But most of the content's there very shortly after GTC concludes. So I highly recommend people check out some of the sessions going, mark the ones you want to check back with, and then you can go to NVIDIA On Demand to watch sessions from previous GTCs. You can go there right now, actually, and look at the content from GTC San Jose. We also have a lot of great top industrial AI sessions happening next week in Taipei. That QR code will show you those sessions. And then these are the sessions I mentioned a few moments ago from March 2026 when we were in San Jose. These are physical AI sessions available on demand. Look at that great panel there. There was so many great panels, so many great sessions. These are the links to tell you everything going on in the world of NVIDIA Omniverse. There's our events page there that lists our live streams, our office hours, our study groups, our major keynotes. That's all in the add event page. You can add it easily to your calendar. Our forums, where a lot of developers will post questions for official support. We have our Discord server, obviously, which is great for user-to-user support. And then we have our community page. I don't know why it's black in there, but maybe Mara has to answer for that. But hopefully you can still read it. That is our QR code for the ambassador listing on our community page. Really helpful. You can read all about Michael Wagner, the ambassadors, Dylan Tobin, Jan, who was there today, Pekka Varis. They're all listed on the Omniverse community page there. Yeah, you can find out more on how to get in touch with them right from that page. And like I said earlier, if you are going to GTC Taipei, it would be amazing for you to let me know, because I'm organizing coffee meetups every morning while we're in Taipei, so we get your day started together, talk about what you're looking forward to most of the day, and kind of compare notes on schedules. Also planning a nice little happy hour for people who were there on Monday night. We'll talk about how everyone liked the keynote and what their big takeaways was. And then the rest of the week, we've got lots of stuff happening, networking opportunities. We're going to try to produce a live stream from there. Well, fingers crossed, no promises, but I'll see if I can find a nice space to do it. And we're also planning to develop interview some developers. So if you're interested in any of those things, hit me up on LinkedIn. You can go to edmar.net. That'll bring you right to my LinkedIn page. That's an easy way to get a hold of me. Or you could shoot me an email, edmar@nvidia.com. That does it for today. Thank you so much for joining us. Big thank you to Michael Wagner for putting together such a great presentation today and showing us how AI agents are transforming 2D to 3D workflows. People were pretty blown away by everything we saw today, including a nice little RTX library demonstration, how to leverage that tool very quickly, and like he said, in about an hour or so. So really excited to see what people do with that now that you have that knowledge. Look at you, Papa Chuck. Let's see how you can take advantage of those steps. All right, that does it for me right now. I'll try to do a live stream next week, but I think we've got other stuff going on also. So look at our calendar for all the study groups, like Michael's happening next Friday, or this Friday actually too. And I'll see you next time. So I'll see you in the forums, on Discord, and anywhere else. Okay, thanks everybody.